In the setup of electrolyzing dilute sodium chloride solution, a few drops of universal indicator are added to the solution. Therefore, the solution becomes pale green in color. When the circuit is closed, the graphite electrode on the right becomes the cathode and the left becomes the anode. Electrons flow from the anode to the cathode via the external circuit. In the dilute sodium chloride solution, there exist sodium ions, hydrogen ions, chloride ions, and hydroxide ions. The chloride ions and hydroxide ions are attracted to the anode, while the sodium ions and hydrogen ions are attracted to the cathode. First, take a look at the cathode. As hydrogen ions are lower than sodium ions in the electrochemical series, hydrogen ions are preferentially discharged to form hydrogen gas. Then we take a look at the anode. Although hydroxide ions are higher than chloride ions in the electrochemical series, the concentration of chloride ions is larger than that of hydroxide ions in the solution. Therefore, the chloride ions are preferentially discharged to form chlorine gas. After a while, we can see that the solution around the anode changes from pale green to red and then colorless. It is because some of the chlorine gas released from the anode dissolves in the solution to form chlorine water, which is acidic and is a bleaching agent. The solution around the cathode changes from pale green to blue. It is because water ionizes continuously to replenish the hydrogen ions discharged. Hence, there is an excess of hydroxide ions around the cathode. The solution then becomes alkaline. In addition, we can see that the volume ratio of gases formed at the cathode and the anode is 1:1. In conclusion, in the process of electrolysis, hydrogen ions and chloride ions are consumed, and hydrogen and chlorine gases are formed. Sodium ions and hydroxide ions are left in the solution. Hence, after a long time, the solution becomes sodium hydroxide solution.